So this is chapter 5, number 7, and our givens are the electron mass of 9.11 times 10 to the negative 31 kilograms, and it says that the initial speed is 3.00 times 10 to the third meters per second, and also the speed increases to 7.00 times 10 to the fifth meters per second in distance of 5.00 centimeters. And then our finds, so the first thing we need to find is the force exerted on the electron, and then for B, it's to compare the force to the weight of the electron. We need to find the force. So we have the formula, which is that the sum of the forces equals ma, mass times acceleration. And then also we're going to need the formula v final squared equals v initial squared plus 2ax. And then this formula actually then converts into a equals v final minus v initial squared, both squared, over 2xf. So we just take this formula and we change it to solve for a. So then therefore, we have the sum of the forces equals m, since we're going back to this with plugging in the a, equals m v final squared minus v initial squared over 2xf. 2x. And then we take this formula and we're going to plug it in. So the sum of the forces equals, so then for m, we're going to plug in our 9.11 times 10 to the negative 31 kilograms. And then we're going to plug in our v finals and initial. So our v final is also taken from our givens, which is our 7.00 times 10 to the fifth meters per second. Squared. And then we're going to square that. 3.00 times 10 to the fifth meters per second squared, squared. And that whole thing is over our 2x. And then the x we're plugging in from our 5.00 centimeters, so then actually the 5.00 centimeters is converted to 0.050 meters. And then so we solve for this, and then this comes out to equal 3.64 times 10 to the negative 18 newtons. And that's A. And for B, f of g equals mg mass times gravity. So then we already have our mass from our given, which was 9.11 times 10 to the negative 31 kilograms. So we're just going to plug that in for our mass. So 9.11 negative 31. And then we multiply that by gravity, which the book uses 9.80 meters per second squared. And then we solve that to equal 8.93 times 10 to the negative 30th newtons. So then what the find was to compare the force to the weight of the electron. So we're going to divide our 8.93 times 10 to the negative 30th newtons divided by 3.64 times 10 to the negative 18 newtons. And then with that, we're going to find that the accelerating force is 4.08 times 10 to the 11th times the weight of the electron. And there you have it.